Stan Gibilisco here with a little discussion about one of the topics covered in this book, Making Everyday Electronics Work. That strange amalgam of scatterbrain notions in electronics. Is it a strange amalgam or is it an amalgam of strangeness? Well, you tell me. Anyway, what I'm going to talk about here is some material covered in Chapter 4 having to do specifically with solar panels and how they should be mounted at various times of year at various latitudes in the northern hemisphere. Now, in any case, you always want to orient your solar panel so that it is facing generally towards the south. Now, in the northern hemisphere, this would be towards the north. Otherwise, these angles would all be the same. In the southern hemisphere, you would point them towards the north, such as Australia, South Africa. In the northern hemisphere, such as in the United States, you would point them south. At the equator, it wouldn't matter. You could point them either north or south. But in any case, these different orientations are optimized for various times of the year. If you want to use a solar panel in a fixed position and optimize it for use all year long, then you should orient it at a certain angle, which would be 90 degrees minus your latitude. So if, for example, you are at 44 degrees north latitude, like I am here, 44 degrees north latitude, then this angle right here would be 46 degrees. If, on the other hand, that would be 46, that's 90 minus 44. If, on the other hand, I decided to move back to Miami, Florida, which is roughly at 26 degrees north latitude, then an optimum all-year position here would be 90 minus 26. Well, you tell me what that is. 90 minus 26. Am I getting old yet? 64 degrees. I should have been able to do that in my head, innit? 64 degrees. That would be this angle. So it would look more like this. I'll get to these situations in a minute. But here is an optimum all-year position. Now, in the winter, of course, at 26 degrees north latitude, the sun is going to come down at pretty close to a 45-degree angle, maybe 40-degree angle with respect to the horizon, or a 60-degree angle with respect to the zenith. In the summertime in Miami, the sun gets to within a couple of degrees of the zenith at the middle of the day. But that is the way that you would orient a solar panel for all year use. If you moved up to, say, Alaska or someplace like that, then this angle would only be about 30 degrees or so. This angle between the zenith and the panel. Now, this particular position right here, if you will go to page, well, now this is figure 4-6 that you're looking at right here on page 101. If you go to page 102, you will see that in the autumn and the winter time, you would use this arrangement at B. Now, by autumn and winter, I am referring to the time between approximately September 21st, the autumnal equinox, and March 21st, the vernal equinox. So that would be mostly October, November, December, January, February, and March. You would turn this solar panel to face a little bit more towards the horizon. In fact, this angle should be approximately 78 degrees minus the latitude. So if I, for example, decided to spend time up here in the Black Hills of South Dakota only during the fall and winter, which is a pretty good time to come up here, by the way, then I would want to orient it at 78 degrees minus the latitude, 34 degrees. 34 degrees is this angle right here. 34 degrees with respect to the zenith. So if I drew a line right through the solar panel like that, it would intersect here at an angle of 34 degrees. If, on the other hand, I decided I got tired of the winters up here, and I wanted to spend the high trajectory solar months, that would be between the vernal equinox of March 21st and the autumnal equinox of September 21st. That would be basically the months of April, May, June, July, August, and September. Then I would orient this solar panel at 102 degrees minus my latitude. In that case here, it would be 58 degrees. 58 degrees would be this angle Z right here. Now, these are optimized positions, and it depends on a lot of factors besides just the latitude. For example, if it's cloudy most afternoons but sunny most mornings, you might want to turn these panels a little more towards the southeast. If it's cloudy most mornings and sunny most afternoons, you might want to turn them a little more towards the southwest. The ideal arrangement, of course, would be something that would optimize this position in such a way that the solar panel would always be at a right angle to the line where the sun shines down, so that the sun would always shine down perpendicular to the solar panel, thereby creating the greatest amount of light intensity per unit area on this solar panel. There's some other considerations in regards to solar panels. If you have a large solar array, several solar panels, you want to make sure that they're all illuminated at the same time. And in particular, you don't want to have part of a solar panel be in the shade and part be in the sun. You want to have the sun shining on the whole thing all at once. So you've got to place these things out where there aren't trees and buildings and other obstructions that would cast shadows over parts of them. The entire solar industry is it's a really good deal right now. Solar panels have come way down in price, and in fact to the point where some of the distributors are having a hard time staying afloat. So I'd really like to get into this. It's just that where I'm at right here in the Black Hills of Dakota Territory, we don't get all that much sun. There are a lot of trees to cast shadows on these things. I've got a million excuses, you know, why I shouldn't do this. But the biggest excuse is it probably wouldn't work very well. And finally, we get hailstorms in the summer here that can drop hailstones as large as or larger than baseballs. If you don't have these things protected against hail, you're going to end up being very disappointed after the next big hailstorm because it's going to destroy them. And if you live in a place where it's really windy, you can imagine what a 75-mile-an-hour wind would do to one of these things if it wasn't anchored down properly. I have a little place out in Cody, Wyoming, and I've thought about solar panels for that. There is a lot of sun out there. There's a lot of wide open space. It doesn't hail very often. A lot of open space, sunshine, great place for solar. But I would really have to anchor those things down because they have had windstorms out there that have gusted to over 100 miles an hour. And don't underestimate the power of moving air. at 100 miles an hour. So anyway, this is a little overview of some of the particulars covered in Chapter 4, Alternative Electricity, in my strange amalgam of electronics trivia known as Making Everyday Electronics Work. You can find this book at my website, sciencewriter.net. Just go up to the Amazon link, and if you want to get a little bit of entertainment, a little bit of tips and tricks for some of your home electronics and vehicle electronics, this ought to be a pretty good buy. Might as well plug my book, hey? Stan Gibilisco, signing off. Until next time, from the Black Hills, once again, of Dakota Territory, where the sun doesn't shine much, the wind doesn't blow a whole lot, but the sky sure can drop big pieces of ice, and lots of snow in the winter, too. Till next time, so long.